All right, ladies and gentlemen, welcome back to the P&K stream again. Wednesday, November 6th, 2019. How's everybody doing? We are working on getting back settled into our normal streams, being that winter's coming up. So we'll be returning to the regularly scheduled program. That includes Mr. D'Antonio joining us sometime soon. Bill as well. So right now we're dealing with a little bit of clouds. Yeah. I hope everybody's having a good week. 2 days left for the Monday through Friday people. My long days start actually right now. So the stream wraps up. Then up at 4 tomorrow morning. And then work all the way till 8 tomorrow night. And then maybe another stream tomorrow night. And then back up at 4 in the morning Friday. And then back home. Stream. Back up at 4 in the morning Saturday. And then home around 5. So yeah. So let the games begin. We got David Schmidt and Justin T and 123 and Jared Bailey and John Petroni, I believe. Who else we got in here? Alex Braun, C&D, 24/7 Arizona Skies, John Beck. I'm just kind of scrolling backwards here. Sorry if I missed you. Deanne Nils or Nillies, not sure. Turk Splitter, Max, Ron. Still going back. Anyway, hello. Hello to everybody. Thanks for joining us. Hopefully, it looks like the clouds are going away from the daytime heating. That's number one. But anytime he goes back to this, that means he sees some clouds in the area. That's why he goes back to the wide field. And as soon as he sees a clear spot, then he'll jump back onto the big scope again. So, besides that, it's not looking half bad. It's looking actually half decent tonight if the air would just settle down a little bit. All right, where's everybody watching from tonight? Let's find out where everybody's from. General areas, once again, do not give me your home address or the chat. If you do, you are asking for it. And, yeah, because Wednesday nights are usually busy nights. I expect this number watching to go up. Steadily climb through the night. And we'll see how long we can be on tonight. We're not even at zenith yet. We're still climbing, so we're going to be here for a while. And I'll be in and out on the microphone. Might bring in a couple people, come in and hang out. So, yeah, just kick back, relax, enjoy the tunes. If you don't like the tunes, go ahead and mute it and play what you want. You're not going to be missing much except for me jumping on here every once in a while. So, yeah, welcome everybody. Hope you have a good time. Let's see what we can see. Keep your eyes peeled. And we got all over the place. We got the UK, and New Zealand, Louisiana, San Diego, California, Brazil. 123's watching from the space station. There it is. Seems legit. New York, another Louisiana, Shreveport. Yeah. All over the place once again. I'm seeing a lot of names popping up. Slot Junkie, of course, Rockstar, and J-Rad, and Barry, and Sean G. That can't be the Sean G, the G of Canada, can it be? How often does the ISIS transfer while streaming? Not very often. You have to be in an exact spot to have it cross over the moon face. It's pretty technical. You can do it, don't get me wrong. You usually have to go to a certain spot, certain coordinates, that you'll be able to catch it actually crossing the front of the moon or the sun or whichever. But I wonder if that is Sean G, the G of Canada. A guy I've known for a pretty long time. And I even say watched grow up back in the day. If you all knew what I did before this. This is a DJ for many, many, many years. Okay, so that's another Sean G. But the other Sean G is, because we have 3 Sean G's subscribed on this channel, I didn't know which one you were. So it's a San Diego Sean G, spelled exactly the same. But welcome either way, Sean. Welcome to Arlen, Scott Avery. Yeah. We're jamming now, I guess. These free YouTube tunes. They make it all worth it, doesn't it? Totally doesn't want to make you shoot yourself in the face with a mullet gun. But hey, we have to do what we have to do. We don't want to catch something and be playing copyrighted music and have YouTube just snap it out from under us, never to be seen again, even though we are recording local copies, which is something about us that you guys should know. Paul is recording on his end, I'm recording on my end, on top of streaming. So in case anything does, whatever, because of some threats out there that we had in the past, of streams being taken down or just stopped in the middle for some apparent reason, we are recording locally. I'm not saying it's anything to do with any government conspiracy or anything like that, but just in case, just know there are 2 local copies. So they will always survive, no matter what. Now, getting it out, that's a whole other thing. But, yes, we are recording. And Mr. Schmidt, how are you doing tonight? Let's see if I can translate Joe here. Aziez les bons moments rouler. Got it. Is that French? Is that Francais? No? This is kind of great danger music, isn't it? By the way, for anybody that doesn't know, the gaming channel is live, where I'm going on there and just wreaking havoc with space pistols and everything else. For some fun times on stuff. I usually do that on nights that we're not doing this. just to kick back and relax. And we did all 3 Mass Effects, and now we're on Andromeda. So if you want that, I'll post a link sometime. If not, no big deal. As I said, it's just a little side thing for people to hang out, you know, if anybody wants something to do. On nights that we're not streaming, or just want to come and hang out and actually use 4-letter words, because on that channel, everything goes. It is not monetized. It isn't, you know, so we can go gung-ho on that channel. And we do. Especially if you have Justin or Rockstar in the chat. Prepare for your little virgin eyes to see stuff they should not see. But hopefully these clouds move out, and hopefully you can still see that shimmy from the wind. He's trying to block it. Something tells me he's going to overturn a golf cart or something and build some kind of Fortnite wall really quick. But yeah. All right, let's go back to the big scope. I'll be back in a minute. I know Mark is streaming right now. It depends on how long he streams. He might actually join us a little bit later. I haven't tried Bill yet. Bill always seems to be pretty busy. Maybe I'll give him a shot. See if he wants to come on for a little bit. Roberto, no, I do not speak Portuguese. I speak two languages pretty much. English and sarcasm from the deep wooded hills of Sarcastaburg. But no, I do not speak Portuguese or Spanish or I can understand it. I can understand Dutch as well and some German. Enough that I can understand what people are saying, but I can't speak it. So no, sorry. Inglés only, sir. If you want me to if you want me to communicate with you. That way I know what you're saying. But I can kind of see what you're saying. So your English is fine. Not a problem, friend. Okay, Dave, so you said Mark said he's going to about 9. That probably makes sense. Being that we're not even at Zenith yet, I see us going a lot longer than that. If I had to guess, I'd say at least 11. But that's just me speculating right now. It's all going to depend on Paul when he says, I'm beat, time to quit. And I'll be like, okay. So, yeah. I'm fully rested up right now, so it's all about him. So we'll go to whenever he wants. So Paul is the decision maker tonight, you know. He went out to get some dinner. Like, in the middle of his stream, he just left? Oh, no, he probably has, like, Amanda or Daryl or somebody there holding it down while he does it. I can't see Mark just leaving. There has to be somebody on with him. Yes, clouds could always decide for us, but they've been on the decrease for the last hour and a half. There was some around, they were like the big puffy clouds, you know, the ones that move really quick. So let's, you know, they're really related to daytime heating. Once the sun goes down, they usually just disappear, which it looks like that's exactly what they're doing. So let's hope, fingers crossed. Let's hope the wind dies down a little bit. Then we can do some major crater diving. Let's hope. As I say, that cloud's roll across. And seems legit. Great. Jinxed it. Nah, we'll find out. There's obviously going to be some passing, but, you know, we'll stick with it. Slot Junkie, you're new here, huh? Yeah, let me let me explain. I'm in Pennsylvania. I'm the one running the stream and basically all the social medias and all that stuff and broadcasting and all that. And Paul is the one running the scope in Miami, Florida. These scopes are down there. He's running all of them. Usually he has 2 or 3 set up. And what he does is he sends that feed to me and then I send it to the world. That way it frees him up to do, to concentrate on the scope work instead of worrying about, talking to people in chat and all that stuff, That's where I come in. That's where my pretty face comes in. And Pancake, I understand a little what you said. Okay, good. And hello to Brandy and FFGGDDSS for good to business. Dude, how did you come up with that name? Did you just pound your fist on your keyboard? Go ahead, be honest. Genius. I've noticed that though in the last year or so, a lot of people are actually starting to use real names or ones you can actually say instead of just weird how they were using zeros for O's or vice versa. And a lot of people are actually putting real names so people can pronounce them, but you stick with it for good. I've seen you around here, so you're good people. No matter what your name is, for good it is. Brandy's with us and CMA Fresh. And of course, Justin and Nancy and David are holding it down on the mod side. Set up a stream for my classes. But yeah, you know what, David? He actually forwarded that to me. And I know we really got to get on the ball with that. And I'm sorry it's taken this long. But we will figure it out. And it just might come down to you being the one that might have to rush, if you know what I mean. Because one day I might send you a message, or Mark might send you a message hey, we can do it tomorrow. You know what I mean? So it just comes in handy that you're, where you are. So when you're teaching classes, we're live at nighttime. So. Well, welcome, Fred. And hello to Hazard's Mirth. I wouldn't say your name's better. I mean, seems legit. Look at Clavius. This is the time of the cycle where Clavius just really comes out and starts popping. You got, big crater to small crater inside of a crater. Perfectly arcing. Our amazing moon. Our very, very atmospheric wobbly moon right now. But it's still not bad. You notice that? Still, even though it's very... the atmospherics are really getting to it, it's still not bad. It's still pretty crisp when it comes to the lines between light and dark and where the shadows are falling and whatnot. Until the clouds go across, as I say that. Of course they would, because why wouldn't they? Now it just looks like soup. Great. Hello, Ryan Valley. Have you explored the known landing sites? There's really nothing to explore. You can't get in close. We could have a telescope that was 30 meters the size of the ones on, the Hawaiian Islands, and we still couldn't get close to the surface. You just can't see any detail. It's called, the Dawes limit or diffraction limit. and that's limiting your capability to how far you can see. You can read up on it if you want to, but no Earth-based telescope, it doesn't matter how big it is, you know, you're not going to be able to see any of the landing sites or any details. We did the math one time, and in order to see the Apollo site, the entire Apollo 11 site, we would need a 130 meter telescope to resolve it to just 2 pixels. 130 meters. That's insane, and then you can't build something like that. It's just nutty. So, you know, that's why they have the lunar orbiter, you know, taking pictures from, you know, 30 miles up or whatever it is, you know, with those high definition pictures. And you can see them all on the LRO Quick Map site. You can zoom in with amazing detail on any part of the moon, and it pretty much has, I'm going to say 93% of the moon mapped. So if you want to check it out and zoom in on stuff, just go to the LRO Quick Map, and you can look at whatever you want. You can even put different times of where the sun's hitting and everything, and different phases, and you can see it, how it looks differently between each phase. It's a good site. But if you get there, you'll get addicted and be there for hours, just so you know. But it's definitely a site I highly recommend. Actually, Fred, we did the math on that too. Actually, the smallest ones, the very smallest ones we can see with this telescope at full zoom are about 11 miles across. If they're any smaller than that, we really don't see them. Unless it's like unless a crater is really cutting with a sharp line of contrast from the shadows. But yeah, about 11 miles is about what we're pulling in. At this zoom, you're probably looking more like 20, but we can zoom in a lot more than this once it calms down a little bit. So yeah, so my guess would probably be, I mean, I know we did 11, but I'm thinking we could probably see ones that are 6 or 7 miles across, but probably no less than that. Hazards from Earth, you can go do that right now on your own. Just go to the LRO Quick Map site, punch in those coordinates, and it'll take you right to it. Skunk, because you're talking about, you know, just collecting photons, not resolving power. You understand? I'm not sure how to explain it any better than that. Yeah. Like, light years of collecting photons, and usually when you're collecting, I mean, they're doing very, very, very long exposures. And you really don't see any detail unless the one taking the picture is actually in space without any kind of atmospheric interference or anything like that. Well, there's your problem. You're using Google Earth. Don't use Google Earth. Google Earth sucks. If you compare Google Earth to the LRO Quick Map, there's no comparison. With the LRO Quick Map, they're all TIFF images, so they're very, very, very high resolution and zoomable. You can see all the way down to things that are half a meter. Like that's how much zoom these things have that you can zoom in on. You can see every little individual boulder inside. You can run up and down crater walls and everything because it's not that far above the surface of the moon taking these pictures. So yeah, don't use Google Moon. Google Moon is horrible. Go to the LRO Quick Map and be amazed.
Listen up. Soap you shower with?
Be clear up to here without moving the scope. So, I wonder if we can see the Andromeda Galaxy here yet. I don't know. Should we try? Yes, we should. I might have to move the dome though. But we're gonna go anyway. How will we know? Well, let's just show the dome. Let's take a look. Okay, off we go. First I have to do this. I want to do this. Say off we go. And now we bring up our image. And you see the telescope moving in the dome right there. Yeah, and it's trying to look there, and it looks like we might be just a bit eclipsing the edge of the dome, but we're going to find out. I have the infrared camera on in there, that's why it looks bright in there, but it's actually dark. Okay, well, now we're there. We might be okay. I'll have to see. We might be okay. Alright. So, first things first, we'll go to full screen here. And let's go to 4K mode. It's right there. I can see it. So now let's bring it over. Okay. Alrighty, and then we'll just bring it up a little bit. And this is the 10-inch now we're using. Okay. I'll go over a little more and then come back. Okay, now we can shut that mode off. Alright, now we'll do 15 seconds at 12,800 ISO. Let's see what we got. Here it comes. Ooh. Hey, look at that. We're clear. Okay. This is pointing out something to me. We've got one issue there and one issue there. These are little blotches on the corrector plate at the end of the telescope. So I will cure those. The blue you see around here, or the green in your view there, this is actually, okay, now it's proper. What we're seeing here is moonlight that is spilling up to this area of the sky. But this is the Andromeda Galaxy, and we have a clear view. Not bad at all. 2 million light years away, heading for our world, for our galaxy. We're going to collide in a few billion years with it. But what's a galaxy collision anyway? The stars will pass right through each other. They pass right past each other, I should say. And there won't be any collisions of stars. But when the galaxy does begin to merge and pass through ours, it's possible that many of the stars will be dragged along with the mass of the Andromeda Galaxy, which has almost 1 trillion stars in it compared to our 100 billion or 400 billion at the outside. It may have a trillion or more stars, and if that's the case, it's going to have a more high collective mass. So when it passes through our galaxy, it's probably going to steal a bunch of stars and take them with them. But we're not small prize either. I mean, we do have enough gravity of our own, mutual gravity, to disrupt the shape of the Andromeda Galaxy as well. And we've noticed in space, looking at galaxies that are in collision, that their disks that they have, the disks of light that you see, disks of stars, they warp. And that warpage is due to the fact that there's a gravitational pull being engaged upon the outer part of the disk of a galaxy from another approaching galaxy. And this warp is really something that's pretty amazing. Let's see if we can do a little processing on this. There we go. A little instant processing, kind of give us a little more detail. Yeah, nice. Now before we do much more, let's go back to our full screen mode, and I'm gonna move this over a little bit this way, actually the other way. Okay. Now I'm gonna go and jump this up to 25,600 ISO for 15 seconds. Make it so, number one. Number one, make it so. My voice has been failing today, so I can't do any Captain Kirk's and Jean-Luc Picard's very well, so I have to wait for me to get better. So let's see where we are. Okay. Alright, so now we can see. Yeah. You can see the dark lane here. All these things show up better when there's no moon in the sky, because we're competing with the moon, adding noise to our view as well. Which stinks, it always stinks, but can't do anything about it. Well, we could blow up the moon. We should blow up the moon. You know what? That's a good idea. We're going to blow up the moon. I wonder... Thanks, Carol. I wonder... do any of you understand or know what would happen? What are the immediate effects that would happen to the Earth if the moon blew up? Just think about it. Immediate effects if the moon blew up. And while you're doing that thought process, I'm going to take you through another object or two. Let's see where our telescope was aimed. I don't think we're going to be able to... yeah, we're not going to be able to go down this way more, because that's going to put us into the dome. So really, we only have up here right now to mess with without moving the dome. And what can I find up here for us to look at? Objects that are faint are just going to be kind of not good for us to look at tonight. Pegasus is here, the great square of Pegasus, but Pegasus, of course, is the flying horse. And now you can see him here, he's sort of upside down. Okay, and you got Pisces. Okay, so there he is. Well, the thing with Pegasus is, there really is no astronomical object of any value that we want to see in Pegasus. There's nothing there. There's a couple of things, a little galaxy here. This is an active galaxy. It's called an interacting galaxy. And it's pretty faint, but you know what? While we're here, why don't we just try and see it? So we're going to go check it out. So you'll see the little stars down here, and look for the stars to move now as we go. Okay, they're on their way. The telescope is moving back into the view, as you can see. And every now and then we're going to see a star pass through the field. It's already going to be done there. All right, Charles, you say the oceans would be decimated. Tell me. Well, D, I'm asking you, what would it actually do? All right, Dan, thanks for coming along. Great to see you. Neutrino? Okay, there you're on the right track there. If the moon just disappeared right now, we'll say the obvious, okay? Which isn't so obvious. That is that the oceans would now lose the tidal bulge catastrophically. So if the moon blew up, then the gravity of the moon is no longer there, at least not in that point. It'd be distributed in the mass of particles moving away from the moon. And let's actually look at a possibility here that maybe that you were if you're looking at the sorry, I was reading Keith's message. Thank you, Keith. And that's what's I gotta just come back to this. If the moon destroyed itself, then the mass of the moon would be distributed into a much larger local area as that particles are raining away from the moon. Let's pretend that the Earth isn't going to get hit by any of them. Okay? So right away, the tidal bulge would relax. That's caused by the moon. However, the tidal bulge by the sun would not. So that means that, and we have about half the height of the tides from the sun, not just the moon. Okay, so we would actually see the tidal bulge relaxing, and the whole Earth would get sloshed. Okay, so for those of you like Neutrino suggested in our chat, coastal cities would die. Well, there would be massive tsunamis all over the world, and they'd have some hours perhaps of warning, and I think it's pretty cool. That they would have some hours, but I don't know whether that would be helpful because we don't have technology to defeat, the problem of tsunamis. Just look at Fukushima, and the whole thing is power plants are put on the shorelines, to take advantage of cooling waters and stuff like that. Well, they would get decimated, so we'd also lose power for a lot of the world. Well, and Charles just saying, well, yeah, stagnant tidal, and there's actually, it wouldn't be stagnant, okay? And as I said, the sun has tides about half the height of the moon. So even if we had no moon, we would still have tide pools where creatures would be exposed to short periods of air. They'd have to get used to it, so it might take longer for creatures to colonize the land, because they wouldn't have been exposed for the depth of time that they would with the moon. But you still would be exposed. So anyway, it's pretty cool. I think that it's a really neat potential. Now, where were we? Okay, we're back here, and we're going to talk about more of those in just a minute. So here in our planetarium, we got this. The live view is here on the left. We can't see anything. Why? Well, because in this view, there's only a couple stars that are visible, but they're faint. All right? So if we bring back our planetarium now, we're on this little interacting galaxy. It's magnitude 11.31. All right? It's in Pegasus. It's one of the only things in Pegasus, and it's 57 million light years away. So let's do a 15-second exposure at 25,600 to see if we can capture it, okay? So here we go. We're doing the exposure now. So while we're doing that, let's poke around, see what else. Okay, the exposure is being done, and when it's done, we're going to jump over and check it out and see if we can see that little galaxy, that little interacting galaxy up here in the great square of Pegasus. Okay, it's done. Let's go see what we got. Yeah, it's really hard to see, isn't it? But it's right here. There's your interacting galaxy. Now, we don't have a tremendous amount of detail because the moon is out. But if I can process a little more, like I just did, let's go in here and let's grab and do some color changes and some corrections. And let's up some of this, and let's see if we can actually get a better view. The galaxy, like I said, is right here. Do you see it? Yeah, it's kind of hard to see it, I know. But you know what? The fact that we can see it is kind of an amazing thing. It really is, because this little galaxy, it's interacting, which means that it's actually interacting with something. So it's pretty cool. This is unprocessed, but it's still false color. We're not really in the full full color here. Hello, Leslie. Leslie Trailer, how are you? Oh, I'm so glad. This is fantastic. Fort Worth, Texas. Well, welcome to the live stream. I think that's really good of you to show up, Leslie, and hang out with us. Make sure you subscribe if you haven't. You know, subscribe to get a notification. If you click the bell, because on clear nights we do this. And this is the telescope that we are moving to Arizona under a dark sky. I'm heading out there tomorrow from Connecticut here to survey the new observatory site. But then I got to go out. I'm going to have only about 4 days to survey the site. I'm going to be there from tomorrow to the 18th. So I have to teach the Mutual UFO Network boot camp in part with a bunch of other amazing instructors from the 8th through the 10th in the desert. And then on the 13th, or 12th rather, I have to be, they're flying me to LA, not MUFON, but a production company. They're flying me to LA because I have to do an Ancient Aliens episode with Travis Taylor, who is actually a PhD physicist in optical science, which is fantastic. You know, so we'll be able to talk turkey. It'll be great. And then the day after, I meet with writers for another project out there in LA, and then I come back to Arizona again, and then I can go out to the desert and survey my observatory site. And then I come back. To Connecticut, drooling probably at the fact that I had such beautiful skies. I am bringing not a telescope, but a star tracker with me, and I'm going to take photos in the desert at the observatory site to actually get an idea of what I'm in for. I've done this before, but not with a tracker. I've just done 20-second photographs using my very high-end cameras, looking up into the sky. Now I'm going to put a tracker on there so I can take longer exposures. I have no idea what I'm in for. I probably won't go to bed at night if it's clear. But I'll tell you one thing. The moon's going to be out. It's probably going to be near full, so it won't be too exciting. But I'm going to give it a shot anyway, because it's very important to survey the site at all times, of the year. Anyway, there's our little interacting galaxy we saw. That's pretty cool. And now, and that's pretty much the only object in Pegasus. Can you believe it? I mean, and if you're thinking about the Andromeda Galaxy, that was over here, and that's in Andromeda. Now, we can't go down to the Triangulum Galaxy yet, because that would put us out of the way of the dome. If you look, here's the dome. Okay, and well, now I'm beginning to doubt myself. Let's try. I think we're going to go down below the level of the dome, but let's just go for it and see, huh? So I'm going to tell it to go there, and we'll see what it looks like in the dome. So here we go. Telescope is moving now. You can see it moving there. And we probably are a little bit in the dome there. And the way we figure this out is I have a red light on in the dome. That's actually not this color. This is actually just the infrared system. It's picking up ambient light. It's beaming an infrared signal and getting the infrared light back and then translating it into visible light. So now what we're going to do is just take a quick picture of this. I'll do 10 seconds at 25,600 to see if the dome is in the way. If it is not, then we will take some pictures. By the way, I want to say to Marianne Robb, who's been very good to me out there in Arizona, I want to say hello again, and I will see you tomorrow when the plane lands, because I think you're the one picking me up. If not, I'll Uber in. Yeah, see, I got dome in here, so this is not a good thing. But you can see right here, this is M33, another galaxy, the galaxy in Triangulum, and these spots have to go. I'm gonna come when I get back. I'm gonna get in there and get rid of these things. I can't stand having optics that are dirty. These are clean, and they're actually very tiny spots, but they get magnified. Okay, so that's no good. Alright, so we can't go and look that far down, as I said, yet. But while we're here, let's go back to the moon, because it's always fun to look at. And for those that are just coming in, they might want to see the moon. The telescope's moving now. Can I prove it? Sure, here we go. There you go, see it? You're looking at it moving. Whoa, there's the moon. As we're pulling into the moon, keep your arms and feet inside the spacecraft at all times. Okay. And now let's bring this up a little bit and see what we get. Maybe there'll be something to see. Yeah, actually I'll show you something pretty cool. Well, it's overexposed a little. I'll go to full screen for this. Okay, now if you look, I'm going to make it brighter. Whoops, I went the wrong way. Sorry. Okay, so let's go to here, and as I make it brighter, okay, I'm gonna have to show you by going this way. Can you see the unlit side? Yeah, it's a little hard to see. But as I move it back and forth, you can actually see, there it is right there. You can see the unlit side pretty well. Not pretty well, but interestingly, you can see it. So that's just a ball being lit up selectively as it goes around our planet, which is kind of cool. Now having done that, we can drop the exposure down, which I'm doing now. I'll actually show you what I'm doing, because that way you'll know what I'm doing. I'm dropping the sensitivity now, and now you start to see it. You can see our histogram down here change as we're spreading the data a little bit more properly. Okay, and then we're coming down. You'll see it change here pretty dramatically. Let me get rid of the 15 seconds. Let's bring this down. Now you can see it change really rapidly. Okay, here we go. And I'm going to go down even lower, because I'm going to move it now into our view a little more. Move westward. Westward ho. And now you want to know where we are. Well, I can just show you, because here we are in the sky. And okay, so now what I'll do is get rid of that. So that's where we are, and right now we are southwest. in the horizon. That's the southwestern horizon with the moon right there. Pretty cool. Not bad. All right, and now if we make this a little bit longer exposure, it'll get a little brighter. And then we can watch the moon again. Now I'm going to go down below 320 though. The smaller the ISO sensitivity, the smaller the sensitivity.
For anybody just coming in, we are just watching the live stream from Mark D'Antonio and Sky Tour live stream until these rain clouds passed. Once they're back up, which it looks like it just might be now, it looks like Paul's realigning, then we'll jump back to our stuff. Just giving you a heads up.
Alright, and let's go back to our full view here and bring up our planetarium view. And now what we'll do is let's just actually take this picture and then we'll go to go see it. And there it is. Ta-da! Looks really pretty. Okay. Yeah, see? How pretty. And I do this because you like this, it's a slightly lower exposure so you can see all the different variations here. These dark areas are called the Maria, the areas that flooded with lava in the early moon history. And you can see that the moon is just peppered with quite literally billions of craters. And the reason is because of the fact that the moon was born of the Earth when a Mars-sized object struck the Earth. That is the prevailing theory. And so when it coalesced into a sphere again from all this debris, there was a lot of debris around the Earth, kind of like a ring around the Earth, I'm sure. And over time, that material slammed into the moon as the moon swept it up, and it peppered it. Some things were very big. This is a giant circular crash site of a meteor or an asteroid-sized thing at one point. This is two. This is two. Okay, this is two. Okay, this was, obviously. So you see